Hey, welcome back to the channel. Good to see you again. Thanks for joining, and hope you're all well. I just want to say Merry Christmas, because this video is going to be released Christmas Eve, I believe. So yeah, I wanted to do something special for Christmas, my Christmas episode. And I really had, I was torn between two items. I had another item that was a vintage open reel deck, open reel tape deck, and it was an Iowa. But then I decided I want to do this because when I did the Pioneer QX747 video, I brought this out expecting it to work, and it didn't, and I was kind of disappointed. I've used this turntable for a lot of years, and it always performed faithfully, but then the day I plugged it in a few months back and tried it, it wouldn't do anything. So this is kind of a unique turntable. This is a Technics SL-7. I'll explain why it's so unique in itself. It's got a lot of features and a lot of specs that are probably above and beyond what it needs to be. But it is a very, very high-end turntable that was back in the day. Now you're probably wondering where I got this turntable from. Well, I bought it brand new back in April 1981. So yeah, and I paid a whopping $630 for it, no tax. So that was a lot of money back in those days, especially for a kid my age. In 1981 dollars, it was huge. But I bought it because I wanted a turntable that was going to perform, and this is the one that fit the bill. You could walk into a stereo store and you could probably drop a lot of money on turntables, and I don't think any of them would perform as good as this one did, and I was happy with it. I still have the manual, the original owner's manual. So a 40-year-old turntable, what's wrong with it? Well, let's try it out. I have it plugged in. Let's turn the power on. We do get power light, but they're kind of really dim. There's a light here in the tone arm. There's an LED, and then there's an LED here that shines down onto the strobe disc. There's a strobe cut into the hub here. And with no record, if I hit start, with no record, it'll spin and then shut down. No, it's not even doing that. It seems like the servo can't even lock. It is running at the wrong speed. Or something's rubbing. It's not doing anything. Okay, let's stop this. Something's rubbing too. Let's put this on auto. Start. Okay, and it shuts down. What it's doing is it's sensing there's no album on the deck, on the platter, and it shuts itself down. It's a fully automatic turntable. It has a lot of features. Quite a few. The main obvious one is it's a linear tracker. And in my opinion, these provide superior playback of albums because, as you know, most albums are recorded on a linear tracker. So there's no angular distortion here as the tone arm goes across the record. There's no angular displacement on the record to give any kind of distortion or phase shift in the music. So that's number one. The number two feature of this turntable that makes it really unique is its mass. It has, shut this off. It is very heavy. It has a zinc die-cast base, and it weighs 7 kilograms, probably about 15-16 pounds. So it has a huge mass, and that's beneficial because if you have this sitting on a shelf or on top of your receiver or wherever you locate your turntable, any vibrations on the table or desk won't transfer through to the tone arm because of this heavy mass, or it'll be reduced. Now another feature it has a very short tone arm, and this is for a reason. because it has to do with the resonant frequency of tone arms. If you know much about tone arms on turntables, is that they can resonate themselves as the record spins and it's picking up the vibrations from the album. The tone arm itself can vibrate and introduce resonant tones into the music. This one has a very short tone arm and it doesn't do that. Well, in theory anyways, it probably does, but it's not as bad or as noticeable. Another feature this has, it's fully automatic. All you do is you load a record, drop it down, close the lid, and press start. And the turntable takes care of all the rest. What it does is it starts the spin up cycle. It's got a little microprocessor in there. There's slots cut in the platter, and there's 3 LEDs back here on the base, and there's 3 opto eyes here, and they sense the size of the album. If it's a 12-inch album, all 3 of these holes will be blocked. If it's a 10-inch album, then 2 of these holes will be blocked, and if it's a 7-inch, just the 1 hole will be blocked. So then it knows what album you throw on it. And of course, if there's no album at all, like I'm doing here, it just does a spin or half a spin, and then it shuts down because it knows there's no album. If there was an album, it would spin up to speed, and then the tone arm would drop according to what size the album is. It would either move in and drop, or it would just drop for a 12-inch. So it's fully automatic that way. You can sense the speed, the size of the album, and from that it also determines the speed. So you have this set to auto, and it will automatically set the speed for the motor, either at 33 1/3 or 45 RPM. But it's also manual. You can have manual override. Plus you have manual override on the size selector. It's automatic in the sense that once it hits the end, tone arm picks up and travels back to the beginning. You have the option of hitting the repeat button, which allows you to repeat the album over and over. Or if it's not on repeat, it'll shut down and it'll stop. It's a nice little compact unit. It's the size of an album. It is exactly the size of an album. Very compact, which is another reason I liked it. It was very nice compact unit, and it's a good performer. I like the automatic features. So not many turntables from 1981 could touch this. And they're kind of highly sought after nowadays. I've been kind of keeping an eye on these on the used market, and they do come up, and they come up for some pretty healthy prices. But this one has problems. Let's go through and we'll load an album and we'll see what it does or it doesn't do. Alright, so for this test I'm going to be using Frank Zappa's Joe's Garage. And oh dear, look at that. We can't show that nowadays. So let's try this out. It's a well-played album. Okay, so we got discs loaded. Power is on. Shut the lid. Hit start. We'll see what it does. And the tone arm does not drop. This is my cueing button, so this is for raising and lowering the tone arm. It sounds like the electrical is working. I can hear a solenoid inside kicking when I hit the button, but the tone arm is stuck in the up. Oh, you know what? Duh, I had the tone arm lock on, so let's take that off. It's a transport lock. Right here is a lock, and this locks the tone arm in position. And you just swing this down and out, and then the tone arm is free. Okay, so let's try this again. So hit power, start, and the tone arm does drop. Let's get an amplifier here so we can listen to it. Okay. Okay, so I have as my phono amplifier, I got a Realistic SA-155, and it does have a phono amplifier in it, so we're going to use that. So let's try this out now. This is all copyrighted material, so I can't play much of it, so I'm just going to start the album.
This is the central.
Now I'm just going to wait a while for this to go. What's supposed to happen is there's an optical system in the back end of the tone arm, and it senses when the tone arm is sitting at an angle. And as the tone arm angles towards this inside center of the album, it senses that, and it's supposed to turn on a motor, and the motor is supposed to skate the tone arm assembly across the record. But this isn't happening. The tone arm hasn't moved. So what's going to happen is the tone arm is going to angle over, and then it's going to hit a stop, and then it can't go any farther, and then the record's just going to start skipping. So let's see if we can find that spot. It hasn't hit that spot yet, and it's sitting at quite an angle right now. But we'll just have a little listen here. Haven't hit it yet. There it is. So it's skipping, and that tone arm is supposed to skate across with the stylus, but it's not. This tone arm is at quite an angle right now. So we know the direct drive motor is working. The stylus and the cartridge is working. I do know that years ago I had a problem with this turntable where one of the channels would cut out when you're listening to it. The music would just die down and it'd go quiet. And I traced it down to a set of dirty relay contacts on the board, because as you cue the record, when you cue the record, the stylus down, part of the cue function is that relay would open and close, and then what it would do, it would mute the phono signal at the same time. Another thing we need to do is figure out why the tone arm is not tracking. Inside this cover here is the mechanism for pulling the tone arm over, and it just doesn't seem to be working. Even if I try it manually, okay, let's raise the tone arm and try skating it over. Either the motor seized or the belt has slipped, but I don't even hear a motor. You should be able to hear a motor go, goes across. It's really quiet. I don't hear anything. Another problem I have with this turntable is the lid and its latching mechanism. It's a known problem for all the SL-7 turntables. This acrylic cast lid has a little catch here and a little catch here that locks on these two plastic. And when you press the button, these pull in and allows the lid to rise. But this side's broken and it doesn't lock down on this side. This side is still okay, so it locks on the right side but not the left. So I have quite a bit of play. I have about 2 or 3 millimeters here where it's up in the air, so I'm going to see if I can do something about that too. I don't know if you can see this. Here's the plastic, the side that's still good. It has a little hook on the end of the plastic. It's molded into the plastic. It's got a little hook, and this one looks like it might even be cracking. It's hard to say. Maybe it's still good, but if you look at this side, so this side's broken away. There's a little nub missing. Well, what my plan is I'm going to do a full resto on this thing, which means going through and checking caps and making sure the electronics is 100%. I'll probably go through and relubricate the motor. It is 40 years old. What else I want to do is make sure this tone arm assembly is all 100% as well. It probably needs lubrication as well. And we'll go through that. But I think I'm first going to start with this assembly here underneath. So we'll take this cover off and we'll see what we can do for this turntable. So let's start by removing this cover. There is a screw hidden here. So removal of the dust cover, they tell you to take out these 7 screws. Let's see how many I got out here. I've got 6, and then 7th one is there. I'm not exactly sure how this... Okay, here we go. They want you to remove this cartridge as well, but I didn't do that. Okay. And our 7th screw is right here. Here's our belt. The belt is looking pretty tired. Now I'll put a new belt on. And here's the problem. We've got a seized motor. Okay, so I'll remove that motor. Got the power. Now plug the power here. So to remove the motor, I think I have 1 screw here. Plug the motor. I was looking at this, there's no screw holding this motor in. It just appears to be snapped in with the J-hook thing. So I'm just going to give it a little push and disconnect, and then there we go, it just falls right out. And it's stuck in this rubber cocoon from 40 years of sitting. That motor isn't seized, it's not spinning. So, what do we do? This is dried up grease. It's a 4-volt DC motor. Date code 15th of December 1980. And I bought this in April of 81, so that's like 4 months later. It's spinning now, but it's stiff. Let's try a little bit of oil on here. If I can avoid taking this motor apart, that would be great. Still stiff. I'm afraid that bearing in the back is sticking as well. Put some power to it. It's drawing 300 or 30 milliamps. It's got very low torque. So I'm just going to let that spin for a while, and maybe it'll free up. It's down to 10 milliamps now. And some dirt coming out of the bearing. Just going to let that run for a while. Okay, so I had this running for about 10 minutes at 4 volts. This is a very low power precision motor. It draws very little current. At full voltage, it's only drawing 25 milliamps. And what I've done is I've let it run for a while, and then I've given it some fresh oil, and then wipe off the excess. And then it's actually, the dirt is working its way out of the bearing. And I can do this a few times. And what it does is when you wipe out the old oil and add fresh stuff, it gets in there and it cleans out the garbage from the inside the bearing, the old sticky grease or whatever it is, and frees it up, and it works its way out. And we have a 3. It's just right at 3 inches. Now I don't have a 3-inch belt. I do have a 2.9. I think this 2.9 will work. This belt probably would work still, but it's egg-shaped and it's starting to dry out. It's hard to say. I don't want to put that back in. I'll go with a new belt. Alright, so I've had this motor running for about half an hour now, and it's current stabilized at 26 milliamps. And pretty confident the motor is going to work. Take the power off. It has a really low friction. So I'll reassemble that. One thing I want to do is I want to remove this sensor board here, and I want to inspect it, make sure everything's good. If I can get this off. Is it held on with something? One thing I wanted to do is there's an LED on here, and it's used to strobe. This LED is strobed at a certain frequency, and it's used to used on the puck. Here, I'll show you. You can see this has lines cut in the outside edge, and as it rotates, it shows that the turntable is turning at the right speed. It's a strobe, and it's quite a dim LED. I want to replace it with a newer bright one, because this one is really difficult to see. So I'm going to do that as well. But I'm trying to get this out. Another thing is there's actually 3 photo transistors here, and this one here looks pretty dirty. I'm going to clean that. What is holding this in place? There we go. So we got a couple connectors. Okay, I found something kind of interesting here. I was checking these switches. Usually what I do is I put my ohm meter across them. And since this is a 4-wire ohm meter, it's quite sensitive. So have a look at this. That's with the switch open. I'm reading 750. It floats between 600 and 800 kilo ohms. I close the switch. What's going on here? Put my hand near it. It kind of freaks out. I close it, I get about 100 milliohms. When I was doing this before, I was getting about 1.1 ohms, which was unacceptable. So I was working the switch back and forth, and every time I click it, it seems to get a little better. See, now it's down to 73 milliohms. Back up to 135. 100. And then when I open the switch, I'm getting a resistance. And I think it's because there's some glue on here. They put glue on the terminals to coat them. I don't know. So let's see if I can pick this glue off. It's not helping. This glue goes conductive, so I'm just going to try and clean some of this off here. I think I might have broke the circuit now, so let's try this one more time. I can get a good grip on this. Okay. Oh, now it's even worse. Closed, 87 milliohms. Open, 200K. Might have to replace this switch. I don't know. Let me take the screwdriver here and remove it. Figured I might as well do this stuff while I'm in here. Let's have a good look at this switch. There's no reason why it should be conducting like that. Let's try it one more time. Oh, we're back up at 800K. I don't like that leakage there. It's 500K. And what will it take for that to drop to a point where it's going to affect the circuitry? 89 milliohms, that's okay. But this here, now it's at 500K. Let me pull out another switch and see if I... Let's see what we get in this switch. Open. Closed. 70, 80 milliohms. Open. I think I'll replace that switch. I don't know what's going on with it, but it seems to have an internal leakage. And this will just be a drop-in replacement. It's an Omron. Okay, let's check this other one while we're here. This one, I don't know if my leads will reach. Same damn thing. What is going on with these switches? Oh, this one? Okay, closing it. Well, see, look, we're in the 35 ohms. When it's closed, that's no good. Open. 54, 100 ohms. This switch is even worse. $33 ohms. What I'm going to do is replace both these switches. I'm not going to monkey around with them trying to clean them. They're just cheap. They're just cheap switches, so I'll just replace them. Okay, so just in case you were wondering, this is what a good switch should look like. It's open circuit. And then when I close it, 20 milliohms, 22. None of this 3-4 ohms crap. 23, 22, 19, 20. Yeah, that's a good switch. I don't know what the spec is on these contacts, but I bet you it's in about the 20-30 milliohms range. Yeah. You can use this technique on relay contacts too. When you have a receiver or an amplifier and the speaker relay, and you suspect that the relay's bad, just put it on here. And if you have one of these 4-wire ohm meters, put it on there. It's really sensitive and accurate. And power the coil up. And when they close, read the milliohms, how many milliohms on the contacts. It should be down around 20, 30, no more. If you start getting around 100, 200, you're going to start getting funny noises on your output and speakers cutting out. Okay, let me put these switches on. I just want to give you a bit of an update of what I've been doing here. What I did is I replaced both limit switches, the rest switch and the end of play switch, because they were high contact resistance on both of them, so I replaced them both. Now I'm doing lubrication. I also replaced the LED. It was so dim you could barely see it, but now I got a super bright in there, and it's lights everything up here. I can show you. You can see that, how bright it is. So that's ready to go back in. I need to clean the board here a little bit. I'm waiting for this adhesive to set up. I used a little dab of silicone to hold the LED to the board, so I'm just waiting for that to set up. Turn my attention to this mechanism. I got it halfway out, and what I did is I removed one screw here on the end, and this allows you to pull out the slide, the rail, and from here you just let this assembly hang. There's one rubber bumper thing on the end here, and there's a rubber bumper on this end, so you got to make sure those are both in place. And just take contact cleaner, clean this off so it's nice and clean, get all the old grease off. And then I took Q-tips and I went into the bushings and cleaned out these 2 bushings. There's one here and one on this end, and I cleaned them out with the same contact cleaner, just so that it's all dry and clean now. And there's no more dirt. There's a lot of dirt came out of this. Should have showed you when I was doing it, actually. I'm just going to reassemble it now so I can put the rubber cap back on. And we're going to set this back into place. Goes under here. And then this drops in this side. I'm just going to assemble everything dry right now because I don't want to get lubrication all over my hands. I'm just holding here. What's going on? Oh, this part has to go behind. Okay, has to go in behind his lip, the tone arm. So that's in place. There's a little steel keeper and a screw. So let's reattach this. Okay, now I can do my lubrication. Just going to put a little bit on the shaft here, or the slide, and then I'm just going to work the arm back and forth. Let's see if I can get this without this part. Rotate this a bit and get the back side as well. What I'll do is I'll just loosen this screw. And I should be able to just roll this over and put more on the back. Don't want a whole lot. just a light coating. Tighten this down again. Now all I'm going to do is I'm going to apply power to the motor. Actually, I got to put a belt in first. Let's do that next. Don't want to get grease all over the belt. So be very careful around this ring gear because it's all saturated with grease. So very carefully get it on there without touching it. And then it should just hook on. Okay. So what I want to do is just put 4 volts on here. Just gotta just feed it into the connector. Got kind of stiff towards the end there. And then back and forth a few times just to spread all that stuff out. And put some more on. I'm going to go back. Go back and forth a few times. Just spread the grease out. Seems to be stalling. What's going on with the motor? Looks good that way. Stalls. What's going on? What I'm going to do is just remove this platter because it's kind of in the way and I don't like getting it dirty with oil and grease and stuff, so you're just supposed to be able to turn this off and the 45 puck comes out, the little spring, and there's a nut there I need to remove. I don't know what size that is, let me check. Yeah, it's 14 mil. And you ratchet to get this nut off. It's pretty tight. Nut, and then there's a spring washer, a wave spring washer, and I thought there was another washer, but maybe not. Now, if this is stuck on, there's 2 holes here that are threaded. They're for M3 screw. You can put 2 screws in there and use them as like a puller, but this appears to be completely loose now, so I can just lift it out. If I can get my fingers under it. Doesn't want to lift. I can't get my fingers under it to lift it out. I could just pick up the whole thing and let it fall out, but I'm not going to do that. I'm just going to use an M3 screw. Again, a nice long one here. It looks like it's about 30 30 so centimeters. Oh, there's a plastic washer here I didn't see. Okay, and I'll just use the M3 screw to lift it out. The platter is quite heavy. I didn't realize it would be that heavy. Okay, it's quite a, oh, it's got magnetic things hanging onto it too, so put this somewhere, don't let stuff stick to it. Make sure this magnet doesn't get damaged. I'll have to give the platter a clean, it's pretty filthy. Okay, there's another dumbass move on my part. I had the current limiting on my power supply set pretty low, it's 50 milliamps, and this motor wants to draw about 70. Now it goes both directions, no problem. Scoots right over, it's drawing about 80 milliamps, 70 milliamps. When it stalls, it goes up to 200. 70 milliamps this direction. And it's consistent all the way across, and this side going this way takes 80 milliamps. So I'm going to leave that alone, put it all back together. Okay, we're all ready to put this back together. The motor's repaired, it was seized, got a new belt, 2 new switches, a new LED, and it's bright. I think if I move this away from the rest position, as soon as I turn it on, it should return home. Okay, the switch is working, clicked off, everything's back together. I'm going to put the optical slide on here. This is just a door that allows light on some of these photodiodes. So I got to get this in to here, and this just slides on. Actually, you know what? This thing's broken. There's a piece missing. Interesting. It should hook in here, but there's nothing there to hook into. Okay, so I'll have to keep an eye on that when I reassemble. This thing here, I'm just going to put this back together temporarily so I can close the lid and flip it over. Okay, so what do we have to do here? Just like that. Okay, now I have this in the way. Where's it hitting? Okay, my wiring harness isn't good, so I have to fix that. It's hung up down here on this harness. Tuck this away. I'll actually be removing this lid later to do, I'm going to try doing a polish on it, and I'm going to do some cleaning too, so. Okay. Okay, I'll put a few screws in. Okay, that should be good enough. We can just close the lid now, flip it over, and we can work on the bottom. Bottom removal is just remove these 4 screws on the feet. Ooh. bottom cover. A lot going on here. Okay, before I do anything, I want to check these two voltage regulators. We got line voltage here, so I'm going to watch out for that. I suspect one of these voltage regulators is low, so let's try and see if we can get a measurement on this. I'll put this here somewhere where you can see it. Power switch, turn it on. Okay, where are we here? We got ground here. So this is IC1, this is the input, and this is the output. That one's good. So IC2 should be a 5-volt regulator, input, and the output. Okay, yeah, those regulators are good. I am going to check all of the capacitors on this board, and I have a feeling I'm probably just going to end up replacing them. I should unplug this. Just because they're 40 years old now. And the muting relay is gone. I don't know if I still have it in my parts bin or not. I might have to find something else to scab in here because it's missing. Let's take the main board out. Okay. There's still a connector here holding. It's this one here. I give it a lift. I think this is what connects the main board to the motor board. I can get this up. There we go. This connector's out, this connector's out, this connector's out. We have switches lifting with this, and that's being held down. There we go. Another connector here. No, that's not a connector. The service manual warns you that some of these aren't connectors, they're actually soldered to the board. They look like connectors, but you can't pull on them to disconnect them. You have to desolder them. So I'm just going to leave those alone. Mainly what I want to do is ESR all these caps. And I'll probably just end up replacing them. There's not many here. There's probably maybe 20 caps. And they're 40 years old. Probably tired by now. Okay, I just made a decision. I'm going to change all the caps. Reason being, seeing quite a few of them are leaking. This one's leaking, this one's leaking. There's a couple other ones here. Where did I see this one's leaking? And they're all over the board. It's not, you know, this one's bad. I don't know if you can see these. Here, I'm going to zoom in. Maybe you can see these, how bad they are. Not terrible yet, but they have to be. They have to go. I don't know if you can see these. There's one here, and this one here. It's all corrosion under there. This one here. This cap's in the way. Move those caps. Can you see that corrosion? I don't know if you can. Some green corrosion up here. Yeah, so they're all going to come out. They're all past their due date. All right, the recapping is done. I have everything changed out. Don't believe I missed any. Maintenance items. There's a switch here. This is your speed switch. I would recommend spraying some contact cleaner in there, cleaning that switch. And if you have a little deoxit, I would give it a little treatment. Not that this was causing me any problems in the past, but it's probably good for cleaning. Now, onto the motor itself. There's 4 screws that hold the motor to the frame, and then there's 2 screws that hold this cap in place. This cap is just like a bearing cap, and it has on the bottom, it has, I think it's a nylon bushing, and then the bottom of the turntable shaft rides on that. It's a low friction bearing. Let me see if I can clean this out. Yeah, it's a little insert. I don't know if you can see that. It's been inserted and then it's been staked so it doesn't fall out. It's just a little plastic disc, probably Teflon or something that's really low friction. Okay, and then on here we have the bottom of the shaft. Let me take this apart. You pull these 4 screws out, this motor can lift right out. Of course you have to have the platter off. Word of warning, this printed circuit board is very thin and it will snap if you put any pressure on it. So be careful of that. And then I would take a good look at these pins here on this connector. These ones are, this one's cracked, so I'm going to have to resolder this one. But expect to find cracked ones maybe on the ends here, or maybe the whole thing, who knows, depending if you're having problems. There's no need to disassemble this motor other than if you want to relube it. You pull this C-clip off, or E-clip, whatever you want to call it. Take it apart, clean all the bearings, all the old oil, grease, and then you'd have to relubricate it with something. This one feels pretty good. I don't see anything wrong with it, and I think I just might leave it alone. It's really not stiff or anything. It's flowing pretty good. So I'm just going to leave that alone. I'll reassemble all this. I think I'm done in here. I also forgot to mention, check this connector for cracked solders, because this is the mating connector for the one on the motor, and that one can crack as well. Also, the 2 voltage regulators, I forgot to mention those because they crack. I've resoldered these a long time ago, but they will crack from all the thermal cycling. And pretty much any other heavy components like this big switch here, the back side of the switch, you find crack joints on there, and the other connectors that are on around the edge of the board. So just get a good get a magnifying lens and have a good look at these solder joints, because there are cracked ones in here. I'm pretty much guarantee you'll find one. Okay, just a couple things I want to cover with regards to the unit itself. Here's the power supply. There's all this here, and got AC coming in. It's a 1 amp fuse, goes through a full wave bridge rectifier, and then here on test point 2 I measured about 20 volts. I don't know why they specify 35 volt cap. You could probably get away with a 25 volt. But this is your first voltage regulator. This is a 7812 12 volt reg, and comes in. This is the input. This one here is ground. This is the ground for the chassis or the circuit. And number 2 is the 12 volts out, which goes through a switch that is integrated into this DC jack. Now, I don't know why they put a DC jack on here. This is kind of stupid to me because you can feed 12 volts in here and run your turntable. But why would you need that? This concerns me because it's not protected. If you look here, where are we? This part here. If you have something plugged in and it makes the connection, it goes through the fuse, switch, comes back, and this should be plus 12 volts here. This is plus 20, plus 12 volts here. But look, it's direct shot into pin 19 on this chip. I don't know if you can see that. Can you? Pin 19? Yeah, this chip here, pin 19. So if you put reverse polarity on that, it's going to blow up these chips on you. So what I suggest doing is putting a reverse biased diode on this input here, just to protect it from any reverse polarity. It'd make me sleep better at night if I had that. You never know. You know you're not going to do it yourself, but somebody else could. Okay, there's a couple of revised parts that you should be aware of. It's in the service manual. D401 light emitting diode is a new part number. I don't know what they're changing here. The D401 is the LED that's in the tone arm for the indicator. It's got a little arrow on it. Hall sensors, they got a different part number. Switches, they have similar part numbers, but probably an updated part. These two are important. Well, 3. There's a resistor here, R211, and its old value was 68K. New value is supposed to be 56K. This here, 5.68, that's an error in the service manual, so that should be reading 56K ohms. So I looked on my board, and R211 has already been updated to 56K. And the next one, you can see this? Yeah, sure you can. Next one is Capacitor C6c303. This part number here references a ceramic disc part of 100 nanofarads, and the updated part is a polyester 100 nanofarads, 50 volts. Now I looked on the schematic here and I couldn't find C6 and C303. Let's look at. If you look at the power supply here, there's nothing here. But if I go look on my my turntable on the PCB board, it's there. Here, I'll show you. This is all sideways, I'm sorry. So if I look here at the revised drawing of the schematic, there is C6, 100 nanofarad, and C303, 100 nanofarad. They're not drawn in that other schematic, so this is the updated one. Alright, so I'm looking at it here. I got pretty much everything done I wanted to do. I removed the button assemblies. There's one here and one here, and those got a bath and the ultrasonic cleaner, cleaned out all the crap in them. Cleaned off the bottom of the PCB board, removed all the flux. Looks a lot nicer now. Did some resoldering on some connectors. This one here in particular, and this one here. This one here connects to the direct drive motor, and also I found some crack solders on the PCB board on the underside here, so did that as well. Just putting everything back together. I'm not going to bother with the relay. It's a shorting type relay that mutes by shorting out the signal. I'm just going to leave that alone, leave it out. I looked for it in my parts bin. I must have thrown it away. I don't know what I did with that. But one last thing I want to do is I want to add a protection diode to the DC power jack. There's a barrel jack here that you can feed 12 volts in and power this turntable. And there's no protection for reverse polarity. So I'm just going to fix this right now. I'm going to add a diode. So right here on this barrel jack, I'm just going to remove some solder. Remove some solder, make some room. Now I did get my continuity checker out the tip is negative, so the tip here flows through to the back here, and the positive is the barrel of the connector, which is this one. So I'm going to add a little surface mount diode, and this is a onsemi U1J. It's just a basic 1 amp diode. I'm just going to put it right there between the two. I'm going to solder it in place if it'll cooperate. And this should provide reverse polarity protection for that power input. Yeah, you smoke one of these microprocessors, there's no fixing this. Okay, let's see if we can get this. It's not even touching here. Here we go. The other side. Can't see. Okay, so we should have and I put the cathode to the edge of the board towards the positive. So what do we got here? It's cooling off, it's changing. That's open. Looks good. Okay, I think I can close this up now. Okay, so I'm ready to reassemble this. I got my platter cleaned up. Turned out not too bad. I still got, I don't know, scuffs. I might give it another cleaning yet. Who knows? Put this back in. It's quite heavy, this platter. It's got a lot of mass to it. And that's a good thing from a rotational point of view. So let's put this in and let it drop into place. Now we have to add this transparent plastic washer. I think it's kind of a shim maybe, I'm not sure. This wave washer, the spring wave washer, that goes on next. And then we got our nut. Now this nut doesn't have to have crazy torque on it, we just want to get it so it's probably right about there. I don't think you want to give it too much. It's got fine threads, that's why you don't want to crank down on it much. Alright, now we can put our oh dear, this needs to be cleaned. Okay, I'll pop this in the ultrasonic and then we'll come back and reassemble the 45 puck. Okay, so we got our puck cleaned. Let's put the spring in. And this is threaded on the inside. It catches the threads that are on the shaft here. Just tighten it down by hand. We don't need to go crazy. That's all it needs. Lock it down. It's working. It's nice and silent. There's nothing rubbing. Sometimes you get junk that falls down inside this little crack here, and then you'll hear it rubbing. You just might have to remove the turntable platter to clean it out. It's not a big deal. Okay, I think we're ready for a test. Let's put the stylus back in and give her a try. Let's see, we got to do this first. We have to trick it into thinking there's an album here. I'm going to put this on 12-inch. And what that does is it blocks all three holes here for the photo eye. Okay, so I hit start. move this in. This is the first time I've seen it work in years. Okay, shut the power off and let it hang there, and then our tone arm is in position for put the stylus in. Pretty dirty. Let me clean it. The thing about styluses is they pick up a lot of junk, and all that garbage sticks to the assembly. Oh, it's much better. All right. So that's working.
Backstage at the armory.
You always wondered what it's like to go place to play.
It's working fine. What I'm going to do is I'm going to let this play through, and I'm going to see how it tracks. Here's a little demonstration of what this turntable is capable of. It's upside down. You turn it on and hit start. I think start button is this one.
This is the central.
And it plays perfectly.
It is my
That's the tone arm gimbal system is perfectly balanced, and it's quite a nice unit. These are actually, you can buy adapters for mounting these on the wall, and they do have a 45-degree stand that you can put your turntable in. What is going on here? Why did it shut down? There, it just shut down. Went about 4 millimeters into the record, and then it just shut down.
Give me my right.
There, it shut down again. That time it went about 5 millimeters in. Okay, so it's definitely a problem here. Okay, I think I'm just checking a few things here. I think I might be onto something. This switch here, right here, there's a little switch, and it tells the microprocessor when the lid is open or closed. And it's just a simple push button switch. And I'm just going to check the resistance across it. Get my probes on here. Okay, so right now the switch should be open, I believe. I'm getting 8.5K. I'm going to push the switch. $910 ohms. It was reading in the hundreds of ohms earlier before I turned the camera on, so I'm wondering if this switch is dodgy. Here we go. Switch is closed and it's just doing random stuff. So I think that switch needs a good cleaning, to tell you the truth. If that's the problem, it's probably what it's doing is it's probably sensing that the lid's open and then it shuts down. So let's just take the switch out. And I was hoping I didn't have to go in and replace wiring harnesses, because that would be a major job. let's try this out first. Let me see if there's any crack connections here. I don't think there are. Everything looks good. There's actually two switches and they're wired in parallel, so yeah, I'm going to say this switch is dirty. It needs a clean. So let me clean that. I'll use some deoxide on it. And we'll see if we can revive this switch. Okay. Give it a good blast here somewhere if I can get it in. Don't see any spots for. I'm just going to go on the side here. There's a slot cut. Give it a good shot. I was looking through the schematic, and there's another YouTuber that was working on one of these. He says if the wiring harness between the base and the lid breaks, he says these things are trash and you just throw them away. I don't agree with that. You can always replace wires. It's not a big deal. But I was looking at the schematics, and there's really not very many things that would cause the unit to shut down if the wire opened up. There's some optical sensors, and there's some solenoids. There's a motor drive. There's a few other things, and all of those, in the short term, if they opened up for a moment, it wouldn't shut the machine down. It would just do weird stuff, and but it would still continue operating. It wouldn't immediately shut it down. This is the only thing that I can think of that if you open the lid, the switch senses that the lid's open, and then it shuts the machine down, and the tone arm goes back to your park position, right? So let's see what we can do with this. I gave it a couple shots. Okay, let me see here. I can do this here without. And these switches aren't the greatest. Okay, so we got what now? Closed. 0. Open. 8 or 9K, which is normal. Closed. Got 0 now. I'm going to say that switch was bad or dirty. When I first measured it, I was getting hundreds of ohms, and it was jumping all over the place, and it was making it was really random numbers coming up. It was really flaky, but now it seems stable. I'm going to put this back together. I think we're done. So here you can see the little plastic catch that's molded into the lid. There's a little hook there. I don't know if you can see that. It's pretty tiny. It's just a little tiny piece of plastic, and that's what hooks into the latch on the base. This side's intact. Hasn't cracked. I don't see any cracks in it, which is good. And then look at this side. You can see it's broken off. And so this is what, on the left hand side of the turntable, the lid's up about 3-4 millimeters because it's not latching on this side. So I was thinking of a solution for this. I was thinking maybe I could get a piece of metal and just use some adhesive and glue that on there. I would have to shape this better. It's not finished. I'm just wondering if this will work. And I'd have to get some epoxy adhesive to bond that to the inside of the lid. But this aluminum's pretty soft. I don't know. I was trying to cut it and shape it, and it just seems like mush. You just hit it with the tools and it just bends. I think I might be better off with a piece of steel. and cut one out of steel might last longer. I don't know. But the mating piece for this is plastic, so I don't know if that will hurt it. I think I'm just stick with aluminum for now. But I got this too big, and I got it on. I got this bigger than it needs to be, so I can cut it down to size. I want to make it maybe a little bit shorter and a little bit narrower, and then just in this area here, I just rough it up with a Dremel or something, just so that the epoxy bonds to the inside of the acrylic, and I'll have bond the metal to this thing, and hopefully that will hold it. But I'll have to make sure I get this aligned properly. I think it has to be somewhere about here to have a little catch. Plus I can't have this too thick. This is already about 1 millimeter thick, and if I put it too thick, it won't. The little latch won't close on it. So I have to be aware of that too. So I'm going to see what I can come up with for this. Okay, so I had this set for a day or so just so it could set up. I didn't want to take any chances. And it looks pretty good. Let's pull the tape off if I can. And we'll see how it... I might have to trim this with a knife because there's a little bit of epoxy that overspilt. See if I can get this all off. Now, I was thinking about different ways to stick this piece of metal on, aluminum in this case. I was thinking also you could drill a couple little tiny holes in the acrylic and put a screw in. I really didn't like that method because what's going on here? It's a little dirty. I didn't like that because if you crack the lid, then what are you going to do? So there it is. I don't think it looks that offensive. It's a little piece of aluminum. If I wanted to, I could maybe paint it black. Question is, does it work? Probably. I have it set here to be flush with the outside edge of the lid, so it doesn't protrude. And if it did protrude, I could just take a little file and just trim it back. I did have this side, the bottom, protruding, so I'm going to clean that up right now. And it's going to take a little file, and I'm going to just slightly dress this so it doesn't hang down and scratch the base. I'll just slowly take off a little bit. I want to get it as flush as possible. I was looking at this lid, and it is cast as one piece. It's just that they painted the back half of it just to have that black, but it is all cast as one piece. I don't know if this was ever available from Technics as a replacement part. I imagine it was, but you probably couldn't get one today. I know a lot of people have problems with these little teeth breaking off here. And hopefully this is a good solution for it. See, like the bottom the bottom surface here of this acrylic has been painted black. And I don't want to go so deep that I'm taking the paint off, otherwise I'm going to have to find some black paint to put back on it. I probably could have been more careful aligning that. It's turning out not too bad. I'm just going to go down slowly. Just about there. So he's pretty flush now. Just gonna take off the sharp edge. I'm gonna use an air duster here, get rid of all this aluminum. I think it turned out pretty good. Some of you might not like that, but I do. Okay. Now, another thing I did is I ordered something for myself on Amazon. It is a plastic polishing kit. Novus. Let's look at this. Novus, this is a 7100 plastic polish kit. 8-ounce bottles. You have 3 bottles here. I haven't even looked at this yet. And you get a couple of paper towels. So you got number 3 heavy scratch remover. This says prepares acrylic surfaces for number 2 polishing. Okay, so here's the polish. I'm going to find scratch remover. This must be a coarse scratch remover. They're fine. And then they have a cleaner. But I thought it was a final polish, but it's not. It's a cleaner. I didn't look at it that carefully. Anti-fog, anti-static, dust repellent. I'm going to read the directions on these. My plan is to work on this, as you can see how it is scratched up, and it's got lots of swirls and it's kind of dull looking. You can see if we polish this up a bit. So I'm going to try doing that now. Let's give me a break here and I'm going to read through the instructions on the back of the bottles and then we'll get back to it. Okay, so from what I understand, you start with number 3, put it on. Clean the surface first. I did. I blew it off the aluminum shavings and grit that when I was just filing there. Clean cloth. Apply Novus number 3. Firm back and forth strokes at right angles to visual scratches. Reapply polish as needed. Continue polishing until only fine scratches remain. And then use the cloth. Remove the remaining polish. And then after that, you move on to number 2, fine scratch remover. And apply polish circular motion until dry. Buff with clean cloth. Repeat as necessary. And then you finish off with the cleaner. One of the reasons I wanted to get this kit, this is actually a kit. I ordered this on Amazon. You buy 3 bottles, and they give you some cloth. There's paper towels. Oh, what's this? Oh, warning. Paper towels is a lot of some of the vintage receivers, like the Harman Kardon 330, the 430, the 730, the 930, the 630. They all have the plastic acrylic bezel for the tuning indicators, the tuning dial, and a lot of that times it gets scratched up. I wanted to see if this would work as a polish for those to bring it back and restore the luster. We're going to try it on this first. Okay, so let's just go to it. Oh, before I do that, I want to clean it. Just with some glass cleaner. It wasn't dirty, it's just fingerprints and stuff. But I don't know if you can see the swirls in this. I don't know. Can you see that? If I can get the angle right. Let's start on this side. It doesn't look like it's taking any out. You can still see scratches through this. Might have to break out the power tools. There's quite a ding there. Okay, let's buff this. And it looks exactly the same. I don't see any difference. Can you see a difference between one side and the other? It should be cutting through this plastic, and it's not doing anything. Well, I think it's going to take a lot of elbow grease. All right, so is it working? Yes, it is, but it's pretty slow. I did actually this side with the number 3, and it improved quite a bit from what this looks like. This is really scratched here. I don't know if you can see the difference between. Let me see if I can get a different. You see the scratches around those reflections. If you go to this side, it's a little duller, but there's less scratches. Well, they're less deep. They're still there. You can still see them, but they're not as pronounced. So it is working, but it's very slow. Plus, I have some good scratches here. I got a great big deep one here, one here, a scuff. There's another scuff here, and all over pretty much there's little ones. So I think what I'm going to do is I'm going to do some wet sanding, and I'm going to go probably 800 grit. This is probably a little too coarse, but we're going to try a little part of it. And I'm going to do wet sanding. I'm just going to use glass cleaner as a lubricant, and let's just try a little bit of wet sanding here. I want to get these big scratches down here out. It's turning. Let's see how that works. Well, that scratch is gone. We're sure hazy. I'm going to follow this up with finer grits of sandpaper. I got 2000 and I got 2500. 2500 is the finest I got. So that should fix up that haze quite a bit. But it looks like I got that scratch out. There's a deep one here, and there's a deep pit here. I'm not going to try and get that. That might be too much to ask for. Let's try a little bit more here. Kind of concerning when you start taking sandpaper to your lid of your vintage turntable. It doesn't give you a good feeling, but I'm pretty sure we can get all these out with a little bit of work. This one's gone. This one's still here. This one's pretty deep. There's still a few little scratches here that I can see. Let me do the rest of the side, and then we'll switch to a finer grit. Okay, so I switched to 1000 because I think 800 was a little too coarse. So I went to 1000, and it's starting to look a lot better. This scratch is gone. This pit is gone. That pit is still there, but I'm not going to worry about this one. It's the only defect in this whole area now. And it looks like I pretty much cleaned up all of the scratches like this. You can still see the scratches here, but not here. So I'm going to switch to a 2000 grit. I'm going to go over it one more time with the 2000, and then we'll see how it looks after that. So this is what I'm using. It's a Norton product. Black ice, wet sanding. It's for wet sanding only. 2000 grit. You buy this at auto body shops. 2000 2000 grit is quite a bit finer than the 1000, so it should remove a lot of the haze. Actually, it would be nice if I had a little sanding block instead of using my fingers. Feels like I have grit here. If you get a little piece of grit, it can ruin the whole thing just by putting deep gouges in it. Now my method is just doing circles, overlapping circles. So let's see, we can do some straight lines here. Okay, let's leave it at that. Let's wash this off and see how it looks. Still seeing a lot of scratches from the... I'm going to give it another go. It's looking a lot better. I do have a scratch here. There must be some kind of grit on the paper because I'm getting the odd scratch here and there. Yeah, you got to keep this stuff clean. Okay, so I'm going to go on to 2500. That's the finest grit I have. Let's see how it looks after 2500. I don't expect it to be much of an improvement, but it should help. And then we'll move on to a polish. And I'm not using much pressure this time. I'm just going light. Let's see how that looks. It's much better. Okay, I think I'm going to move to a polish. Let's try the number 3 again. Give it a good application of this. See how this turns out. This should be a big difference in, where's my wet spot? Here. This might take a few applications. I don't know. I'm still seeing quite a few scuffs. Let's clean it. Clean it. I got some heavy scuffing going this way. I might have to do some more 2500 here because there is some scuffs. And I still have a swirl pattern. These scratches are just not, these scratches are quite deep. And these ones are quite light. So I'm going to keep going with the number 3 polish and see how we can get this looking. Alright, so that's with 2 applications of the number 3 polish. And I'm still seeing quite a bit of haze and swirls, but I think the number 2 polish should take that out. So let's go on to a number 2. Let's get rid of this. Number 2 polishes a lot. This works out. Yeah, like I said, I wanted to use this kit for doing receivers that have the acrylic plastic front, and I want to see how this works for polishing them up. You know, you got a receiver and it's got all kinds of scratches and dings, and it really lets it down. It's quite a bit of an improvement. It's not perfect, but it's a lot better than this. You can see that. Now, there's still a few scratches here I didn't catch. So maybe more time with the 1000. Maybe more time with the 2500. And maybe more time with the number 3 polish. That ain't bad. Maybe you can see the difference. It still has a haze to it though. And the haze should come out with the number 2. It's more time with the number 2 will get rid of the haze, I'm assuming. Okay, so I'm going to go to town on this side as well, and then we'll see what we can do here. Alright, so I'm going after this full on, and I'm learning a few things here. I don't know if any of you know anything about auto body work, but if you've done any wet sanding on a vehicle, I'm following basically the same process here. Like, you got a paint job, brand new paint job, it's got orange peel on it. So what you want to do is you want to select the right grit of sandpaper to knock that orange peel down so it's flat. And usually you start off with a low grit, like maybe 320 or 600, something that's going to knock down all those hills and bring it down flush with the valleys. We don't need to do that here on this because it's already flat. But then once you knock down all those hills and it's perfectly flat, what you're left with is a flat surface, but it's all scratched, right? Because you're using a sandpaper on it. So that's when you start moving up in grits. You move up to 1000, you move up to 1500, 2000, 2500. And what you're doing each step is you're removing the scratches left behind by the previous sandpaper. That's all you're doing. You're not trying to dig out scratches or any deep things like that. If you have a deep scratch, what you want to do is start with a coarse sandpaper and sand it lightly until that scratch just disappears. Then you know you've gone deep enough and you don't need to go anymore. And then what you do is you start off with the higher sandpaper to remove those scratches you just left behind. And I'm doing the same thing here. So I started off with 1000 and I went through and I sanded the whole thing again with 1000, and I did it a few times, and I'm trying to, it's really hard to tell because you have a lot of haze and you get a lot of fine scratches. But what you want to do is remove all those deep scratches, right? And I don't think I see any more here. So once I finished with the 1000, I did a couple of passes with the 1000 grit, and then what I'm doing now is I moved on to a finer grit, and all the finer grit does is remove the 1000 grit scratches. That's all you're looking for. And it does, you don't have to sand it for an hour. You just sand it until you feel the scratches are gone. And by what I mean feel is your eyes won't tell you, because you're obviously covered with a liquid. It's wet, And what you're doing is you won't be able to see the scratches because they'll be underwater. The secret behind wet sanding is the feel. You're going to feel if the sandpaper's cutting, you'll feel a slight drag, or if it's not cutting, it just glides over the surface. If you hit an area where there's 1,000 grit scratches and you're using a finer grit sandpaper, you're going to feel it cut. And then if you go a few times, the friction, or you'll feel the friction suddenly ease off, and then you'll just feel the paper sliding across. And that's what you want to do, is you want to remove those finer scratches. Now, another thing they tell you with auto body paint sanding, when you're wet sanding paint, is you do it in an X pattern. You sand one way, one direction first, and then you come back and you do it the opposite direction. And what that does is it helps the sandpaper cut the previous scratches out. If you always sand in one direction, you're not going to remove the previous grit scratches. And a lot of, if you like I said, if any of you have done auto body sanding, you know what I'm talking about. So I'm applying the same principles to this, and it seems to be working. I did a few passes with 1,000 grit, and then I've done a few passes with, I've done 2 passes with a 2,500, and I think I'm ready to move on to polish. I think I might have some spots here that are difficult to, right around this edge here. They're kind of difficult to get in there with the sandpaper. I might get in there and finish this again with the 2,500. Everything else looks good. Everything else looks good. So yeah, I'm going to do this more with the 2,500 and finish this off, and then we'll move on to polishes. Now, another pro tip: sandpaper, when you're wet sanding, you throw it on the bench, you pick it up, it's going to have grit on it. You don't see it, but it's there. So before you do any sanding with sandpaper, go to the sink, take it, run it under water, wash this off so that there's no grit, there's no contaminants on here that can put deeper scratches in here. So you want to have a clean piece of sandpaper, and it'd be a good idea to also wash the surface with running water between each step as well, because you want to get rid of any particle of dust or grit that has fallen on this, and it will ruin the whole thing. Okay, well there it is. I finished with the number 2 polish, and I did two polishes of that. It seems to be okay. I still have more scratches on this side than I do this side, because I think I started on this side, and I think I did more 1,000 grit sanding on this side. Actually, I think I started with 800 grit on this side, and I think that helped get rid of a lot of these scratches. Probably should have had 800 grit on this side as well. The 1,000 grit just doesn't seem to be attacking them. Think of a scratch as like a little V groove in the plastic, and it's microscopic, and it's just like a few microns deep. And the idea behind the wet sanding is to remove all the plastic in a uniform manner until the thickness of the plastic comes down and the bottom of that V groove is exposed and removed. So yeah, I probably could have got better result if I started with a coarser grit and went over it one more time and then worked my way up from there. So you got to remember, whatever grit you start with, you don't want to go too low. You don't want to go like 320 or something, because you're going to put big scratches in this. I think starting, depending on how scratched up it is, you might want to start with a 600 grit and see how it goes from there. If you got really deep, ugly scratches, you probably could go coarser and get those scratches out first, and then you work up with a 600, work up with an 800, work up with 1,000. You can't take a 1,500 grit and go after a deep scratch and expect it to work. It just won't. You'll be there all day and you'll be scratching, and what you'll get is you actually won't remove the scratch, but what you'll do is you'll actually transform the scratch into like a valley with softer kind of like softer sides, and you'll see the scratch. It'll be softer, and you'll see the plastic dip down inside and come back out again as you do that. This actually worked pretty good. It turned out a lot better than I thought. This was scratched up to the point where I could hardly see through the acrylic onto the record. So I'm kind of pleased on how this is working, and I think this is going to work a lot better for being able to see the album and where I'm going to be cueing the album. Before I had such a hard time because the reflections from all the scratches were blinding me and I couldn't really see through all that scratch and haze. But I think this is going to be good. I'm going to clean this up, and I still got polishing compound all over. It's still filthy. I'm going to clean this up and then I'm going to put it back on. Alright, so we're hitting the finish line here pretty soon. I just want to go over a few more things. Cartridges. I had installed in this turntable this Audio Technica. This was a TM3. Relatively good cartridge. I liked it. It didn't sound bad to me. It was not as good as the original. This one I think is a little better quality. I think Technics went to some great efforts to provide a good cartridge here. And I was looking at the specs for them, and they're really not that bad. Let's have a look for this cartridge. These came fitted with all the SL-7s. So it's a moving magnet, which is no surprise there. It's no moving coil. Samarium cobalt magnets. One of the main features that this cartridge has is for the Stylus Cantilever. They call it cantilever. It's the stick that comes out of there. Usually they're made of aluminum, and this is made of a pure boron pipe, which gives it less mass. Less mass equals faster frequency response, higher frequency response, more dynamic range. I guess for the purists, they might be able to hear the difference. I don't know. You know, you look at the mass of this Stylus cantilever here, and it's pretty minuscule. If you ripped it out of there and measured it on a scale, it would get you in a few hundredths of a gram. But this one, that much less, so it's much better. So frequency response here, it says 10 hertz to 50 kilohertz. Now that's probably maximum limits, who knows. So plus or minus 1 decibel, we get 20 hertz to 10 kilohertz. Plus or minus 3 dB, which is usually what it's measured at, you get 20 hertz to 35 kilohertz. Stylus pressure range is 1.25 grams, plus or minus quarter of a gram. Now, one thing about this turntable is it has a very limited range of stylus tracking pressure that you can adjust it to. I'll show you that in a bit. It has a stylus tip, 0.3 mil times 0.07 mil elliptical stylus. And I did check it with a loop here, and I looked at it for quite a while, and I don't see any damage to it. It was very dirty when I first pulled it out, so I cleaned it with carefully with a cotton swab and some alcohol, and it came out pretty clean, and I gave it a good look, and that stylus looks fantastic. I don't know, people say that you can only put 1,000 hours on a stylus and then you have to change it. Is that really true? Like, or is it just that the stylus gets dirty and cruddy and then it starts making distortion? I don't know. I'm going to put this one back in. This stylus here is a conical stylus, and I looked at it as well, and it looks pretty good. I don't see any flaws on it. There's no chips, there's no cracks, there's no wear. You know, for a diamond stylus, it holds up pretty good. So I'm going to put this one aside. I'm going to install this one back in. We're going to have a listen. So what's the difference between these two? Technics has a specification of 6 grams, 6.0 grams for the cartridge only. So let's see what this is. This scale is accurate. I use it for measuring gold, and it has been confirmed that it is an accurate scale, even though it's from China. So first of all, let's measure the Audio Technica. And what do we get? We're getting 5.94, a little under 6 grams. P-mount, is that a specification for P-mount cartridges, 6 grams? This one's 6.03, which is not far off from 6 grams. So yeah, is that a specification for P-mount, that it has to be 6 grams exactly? I don't know. Maybe there's some experts out there that know better than I do. So let's put this back in, and we'll check the tone arm tracking weight. Okay, so here is the adjustment. There's a little cutout portal here. We have to put the tone arm back in its own position. So turn it back on. Watch it skate back. And in this little window, there's a little screw adjustment, and then there's also a gauge. There's a line on this side, and you can't see that because the angle's all wrong. Let me twist this. So you have an adjustment, and then we have a mark here, and then there's a scale on the left hand side. There's 3 marks. There's a top line, there's an arrow pointing this way, and their bottom line. And the center mark is your 1.25 grams. That's your factory optimal weight. And you can adjust it up or down 1/4 gram by turning this knob and aligning with one of these other marks. I'm not sure which is, oh yeah, it says right here, minus if you turn it to counterclockwise, plus if you turn it clockwise. You can actually adjust this to track between 1 gram and 1.5 grams. And that's pretty much your range. I'm just going to leave it set for 1.25. There's no really need to adjust the tracking weight up or down if it's optimized for 1.25. So I'm just going to leave that. Well, I think this video's gone long enough, and I've done a lot of work to this turntable to bring it back. I am very pleased with the operation of it now. I did test it out off camera, and it's working fantastic. I gotta admit, I was real hesitant to start this project. Maybe that's why I let it sit on the floor for so long. But yeah, I'm glad to have this turntable back. This is like an old friend of mine that I've used for many years. Like I said, bought it brand new. Got a lot of attachment to this, and I really love the sound of this thing, and the performance and the operation. It's really simple to use, and it's a great turntable. If you ever get your hands on one, get it. So I'm not going to do a demonstration here on this video because of the copyright issues. What I'm going to do is I'm going to make a separate video, and they can copyright flag that one all they want, and I'll post the second, maybe even a third video after this one airs on YouTube. So probably maybe an hour later, after this video comes live on YouTube, the other videos will come live as well, and they'll follow up. And you can go to those other videos and listen to the sound of the turntable. What I'm going to do is I'm going to try dubbing it in directly into the camera. My camera's not very friendly that way. It has a microphone input, and it doesn't like line level. So I built a little attenuator. I tried different levels, and it's not the greatest. The camera itself really mucks around with the sounds, and but we'll talk about that on the next video, and we'll see if you can give you a listen to how this thing sounds, and I'm really pleased with it. So yeah, Merry Christmas to me. I got my turntable back, and I'm happy. So great. So thanks very much for watching. I hope you have a Merry Christmas, and I hope you all well, and we'll see you on the next one. Take care.